Hello, my name is Rodrigo. I'm in the group 112 of Energy and Transformation 2, and today I'm gonna talk about my key activity. It talks about rectilinear motion and kinetic energy. Its name is a car with extra weight. In this report, I'm going to present the results of my experiment. The main topic of this experiment is kinetic and potential energy. When we talk about options of faster ways to transport, we mainly idea that we found are the cars. Since the horsepower cars to the electric cars, we are always looking for better ways to move in our vehicles. But what exactly happens when we analyze the motion of our vehicles? A very common phenomenon occurs. When you have any kind of power source, for example diesel motor, a solar panel, or even the wind, the linear displacement explains us that if we want to find the velocity, we will have to get the time and acceleration. In the equation, v is the final velocity, a is acceleration, v sub 0 is the initial velocity, and finally t is the time. When we solve the equation, we finally get a regular velocity on a certain time, and that's how we analyze the fastest way to move over land. However, there is something that is still missing, and that's the mass of the vehicle and the cargo. And that's where the kinetic energy enters. When we apply the formula using the velocity obtained from the linear motion, we can finally get the mass and also amount of energy that we need to move the vehicle. The kinetic energy is the energy that an object possesses due to movement. The kinetic energy depends on the mass and the speed of the object. According to equation, energy equals 1 mass times velocity square, where m is the mass of the object and v squared is the speed of the object squared. The energy associated with an object at a certain height above the surface is called potential energy. If the object is dropped, the potential energy is converted into kinetic energy. In the equation, K is the kinetic energy, m is the mass, and v is the velocity. So finally, I get the mass and the energy required to move. And that's how we get the velocity and how does it affect by the weight. My research question on this experiment is, with the extra weight, how does it modify the velocity that takes to a car to move 1 meter? Based on this question, my hypothesis is that the average time will have a difference no more than 0.5 meters per second. The variables in this experiment are independent variable, the extra weight that I add to the car, the dependent variable will be the velocity of the car, and the control variable will be the distance that it must move. The materials that I will use will be a tiny box, a balloon, straws, wooden sticks, plastic bottle caps, rubber bands, a mark to measure the distance, a camera to record the experiment, and the tracker apps. The method I use is the next one. First, I tape the balloon below the box and put a straw on the mouth of it. Then I build the axles, putting the wooden sticks through straws and taping it to the bottle box and bottle cups. Finally, I put my phone on the box with the tracker app. With the marks on the floor, I control the distance of the car, and with the video and tracker app, I will control the time that it takes to move 1 meter. Tracker app will get me to get specific data, and I'm going to impulse the car with the air of the balloon from a specific distance of 1 meter. There, I'm gonna record the movement. First, 3 launches with no extra weight, the second with 0.025 kilograms of extra weight, and the third one with 0.05 kilograms. I will use tracker app to get exact time it takes to move 1 meter. Results. Analyzing the results that I get, the first trial with no extra weight get an average velocity of 0.372 meters per second. The second trial with 0.025 extra kilograms, get an average velocity of 0.412 meters per second. And finally, the last trial with 0.05 extra kilograms of weight, get an average velocity of 0.180 meters per second. Now that we know all the information that we need, we can answer the research question. The answer that I am looking for is the difference between the velocity in the three experiments with different weights. So I have to answer this in two different comparisons between the data collection. First, comparison the one with no extra weight with the one with 0.025 kilograms of extra weight. Analyzing both results, I get a different result of what I expected. I was hoping that with the extra weight the car was going to reach less velocity, but the results show me that actually the one with extra weight reached a higher velocity, an average velocity of 0.412 meters per second against a velocity of 372 meters per second. Then I get the results of the cart with 0.05 kilograms of extra weight, and this one get the results that I expected, decreasing in velocity in comparison with the two others, reaching only an average velocity of 0.180 meters per second. In conclusion, my hypothesis was correct, but I was really surprised about the results with the car with 0.25 kilograms. I really didn't expect that. Some changes that I made were the weight, reducing it because the car couldn't handle the first weights that I used. Also the distance because the balloon couldn't impulse the car anymore. And finally, I decided to change the app to measure everything because the original app add unnecessary weight to the car that it couldn't handle it. Also, something that I could change could be the position of the balloon because sometimes it stops the car.